The topic of the session, the new chapter, is coordinate geometry. Now, geometry is already the most famous word in mathematics which we come across. Geometry is study of figures. Now, coordinate geometry is a type of geometry where we connect the coordinates or the x coordinate and y coordinate. So, when we consider the points x and y on a graph sheet, then definitely the kind of graph we are going to consider is part of coordinate geometry. But before we go into the topic of coordinate geometry, let's recap with the chess game. We all know that the rules of the chess game, most of the rules of the chess game are based on the bishop, the knight, the king, the queen, the horse, the elephant, etc. So there are many different pieces through which we play the chess game. Say for example, I take the introduction through a chess game. Then we know that there are different pieces which have the different rules in the game of chess. Say for example, I take the knight. The knight in the chess game always moves in an L-shaped manner. We know that this moves in L-shaped manner. So how do we know how many units it has moved in L shape to right and top, or right and bottom, or left top, left bottom, is how we are going to connect with coordinate geometry. Say for example, my knight here is here. So this knight over here moves L-shaped here. That means once I move 2 steps to the right and 3 steps up, then this is where this has moved finally in L shape. Now I wanted to know the position of the knight after moving in an L-shaped manner. So what is the position of this? Again from here, this moves in L-shaped manner through which I get 1, 2, 1, 2, 3. Say I have again moved on the chessboard to here. So finally, I wanted to know in 2 steps where this knight over here has moved to A and then to B. I want to know the positions of A and B of the moving of the knight in an L-shaped manner on the chessboard. I can locate the position in the chessboard provided I use coordinate geometry. Now, coordinate geometry helps us in identifying the position of the point or position of an object on the particular place. So putting the object on the particular place or position can be done by using coordinate geometry. So what is coordinate geometry? What is its application in real life is what we are going to see for the session. So what is a coordinate geometry? The geometry studied on a graph sheet is nothing but a coordinate geometry in its most simpler words. The definition is the geometry studied on a graph sheet is called coordinate geometry. Now, what are the rules on the graph sheet is very important, because coordinate geometry is more associated with the rules of the graph sheet than that of the graph sheet itself. So what are the rules? Usually when I say coordinates, they are nothing but the points or the values associated with x and y axis. So generally we take an x axis and a y axis which intersect exactly perpendicular to each other. That is, the two axes divide the plane into 4 regions. This is region 1, this is region 2, region 3 and region 4. This is called x-axis and this is called y-axis. So x-axis is the axis along which all x coordinates are taken, and y-axis is the vertical line along which all the y coordinates are considered. And the rule is this is said to be origin because this starts from the initial point, which is called the origin, and the coordinates of origin are 0, 0, where x coordinate is 0 and y coordinate is 0. So when I write the position of the point, I generally denote with xy, where this is called x coordinate and this is called y coordinate. That is, when I take x comma y, I understand that if my point A is x comma y, then it is x units from x-axis and y units from y-axis. This is x and this is y, where I get, just like a knight moving in an L-shaped manner, x units vertically, horizontally, and y units vertically is how I get the position. Similarly, when I take the point B as minus x, y, assuming x and y are positive real numbers, then if I assume them to be positive real numbers in this case, then I get, if I take minus x, y, that means this moves minus x on the left plus x on the right. All the positive x values move on the right and negative values move on the left, plus y on top, minus y values on bottom. Therefore, this would be x units on the left and y units top is how I get this. Similarly, when I take minus x minus y as a coordinate of C, then this is understood as x units from here and y units from here and etc. So finally, we understand that the position of an object can be identified on this 4-plane xy coordinate system by taking the point, and then the coordinates of the point define the object. Say for example, I take 3, 7. That means my object is 3 units from x-axis and 7 units from y-axis is how I understand in the coordinate geometry. So 3 units from x-axis and 7 units from y-axis is how I get the position of the object. So when I take the coordinate geometry, it is always that we take it on the graph sheet, because graph sheet is very accurate in identifying the points to its perfection. Now let's see the distance between 2 points in coordinate geometry, the topic of the session. So if I wanted to find the distance between 2 points, then we have a formula through which we are going to do that. Now let me just initially take the 2 points. Say for example, I wanted to find the distance between 2 points 4, 0 and 6, 0. These are the 2 points where I want to find the distance. So initially, I would like to plot them on the xy coordinate system and then identify the distance. So first, let me plot these 2 points on an xy coordinate system. So when I take the x-axis and the y-axis and the origin, then in this case, initially I plot A and the point B respectively. Now since my A is 4, 0, let me take the coordinates 1, 2, 3, 4, 5, 6, 7, 8, etc. On the left it is -1, -2, -3, -4, etc. 1, 2, 3, 4, etc. -1, -2, -3, -4, etc. Now in this case, how do I plot the point 4, 0? Now 4, 0 makes me understand that the position of A is 4 units to the right of x-axis and 0 units upwards of y-axis. Therefore, 4 units to the right of x-axis and 0 units to the right of y-axis is itself there. So this is the coordinate of A. Similarly, I want to identify the point B on the xy coordinate system. Therefore, I move 6 units to the right and 0 units up. Therefore, when I move 6 units to the right and 0 units up, it is exactly on x-axis. This is the point on x-axis. These are the 2 points identified on x-axis. Now, my question is to find the distance between these 2 points. That is, I wanted to find this distance which I need to find mathematically. How do I find the distance between 2 points? It's clearly understood that if I take this as O, then from the diagram I can make out that distance between A and B is nothing but the distance from O to B minus distance from O to A. This minus this gives me this geometrically. So when I take here, I clearly see that OB minus OA is nothing but AB, is how I understand AB equals OB minus OA. Therefore, my OB, as I can see clearly here, is the distance from origin to B, that is 6 units. As I can see from O to B, it is 6 units. And the distance from O to A is 4 units. Therefore, I get 6 minus 4 as 2, which is the distance AB. Is how I get the distance between 2 points when I study that in this concept. So let's take one more example and see what would be the distance between those 2 points, continued from this example problem.